Okay, can we start? Okay, thanks. Today is it's a very important lecture. I think these are the most important concepts in OOP, and some of these they are not immediate to maybe to understand for some time. So please pay some attention to this. So we will talk about inheritance. So inheritance is the main concept we will explore today. Inheritance implies several other concepts that also we will explore today. So these are the notion of superclass, subclass, overriding, method overriding, and substitution principle, polymorphism, dynamic binding, and also type casting. So all these are lots of concepts. They are all related to inheritance, and we will talk about all this today. A recap so far. So what we've been seeing is classes. Java starts from classes that can be seen as blueprint that we can use to create objects. So objects are not really defined in Java unless as instances of classes. Objects have state and behavior, and the state and the behavior correspond to instance variables and instance methods. Objects are created using constructors. This is something I see still in the labs. There is still some confusion there. When we have, for example, account AC equal new account, the rightmost account is not the name of the class, is the constructor. And we cannot create objects without constructors. We saw last week that there are two kinds of methods in Java. There are the instance methods that relate to objects. They only make sense with objects. They cannot be used without objects. And then we have the class methods that you are familiar from the previous term. And the class methods don't need objects. They don't relate to objects. They do operations without objects. And the same for class variables are variables that are declared in a class, but they are not related to objects. So, for example, they can be used as global variables or constants. So make sure that you understand all these concepts, in particular also for the tests that we will have this week, but also for the final exam. So make sure that you don't have confusions about these notions. Okay, so let's talk about inheritance and what it's about. So here we have a few English sentences like dog is a mammal, cat is a mammal, tiger is a mammal, car is a vehicle, bicycle is a vehicle, truck is a vehicle, and so on. So you see all these sentences are of different nature, but they all have this is a. So you see, when we think dog is a mammal, so we have this generic concept of mammal is a kind of animal with some properties, and the dog is a particular case of mammal. Another particular case of mammal is cat, and also tiger. All these are kind of particular cases of this more general concept. Similar for when we think of car and vehicle. So vehicle is a more general concept than car because there are vehicles that are not cars. For example, trucks, for example, bicycles, for example, ships. So this is a relationship that we establish between more general concepts and more particular concepts. So a vehicle is a more general concept, or in our terms is a more general type than a car or truck. This is what inheritance is about. So inheritance is a way to deal with this relationship between concepts. So in Java terms, car is a subclass of vehicle, or vehicle is a superclass of car. And inheritance is a fundamental concept in object-oriented programming because it allows a subclass to inherit variables and methods from the superclass. In concrete terms, what basically this allows is an economy of code. So instead of having to write lots of code, you can write code in a superclass, and then you don't need to rewrite in the subclasses. From a practical point of view, this is one of the advantages. So now I focus as we have done, we've been trying to explain Java in a principled way. I'm not here to bark orders. Java is this and this and this, and type this and type that. I'm trying to make sense of Java. Why people design the language in this way, why they put these features. And we saw, for example, why there are compile errors when you try to call an instance method from a class method, because the lifespan of class methods and instance method is different. So we make sense of this compile error. And similarly here, we make sense of Java, of inheritance, in terms of this is a relationship. I see in several textbooks, while this is the principled way of explaining inheritance, other textbooks, they just basically dump on the reader just is the inheritance relationship, like just you have a superclass, and then you decide what is a subclass, and you add the stuff, which doesn't make much sense. So I insist that if we want to understand inheritance and the reason things work well in inheritance, we should try to understand in terms of this is a relationship. So a car is a subclass of a vehicle because a car is a more particular concept than vehicle, or vehicle is a more general concept of car. In fact, I hope that there are some philosophers in the audience. This is not a very new concept. This is the starting point of logic, of formal logic. For the philosophers in the audience, if you remember syllogism, so the Aristotelian rules for logical correct inference, that is inheritance what is about. So syllogism, the famous syllogism is all men are mortal, Socrates is a man, therefore Socrates is mortal. Yeah? Well, the validity of inheritance, so why okay to say that Socrates is mortal from those two premises is because Socrates is a man. Hence, he inherits all property of being a man, in particular, mortality. Yeah? So, the inheritance relation between concept, it makes sense, it makes logical sense for any concept that is a relationship. And why? Well, that's exactly because of the fundamental law of logic, syllogistic reasoning. So whatever you can think of the superclass, that will be that concept will be inherited by a more specific concept. Okay, so let's now see how this is implemented in Java. So we have a keyword, extends, when we want to declare a subclass in relation to a superclass. One thing that we should point out is that what is inherited in the subclass is not everything, is everything apart whatever we declared as private. Yeah? As we saw in the first, as we said in the first lectures, in Java, whenever you declare a variable or a method as private, that means that entity can only be accessed and used inside that class, is private to that class. In particular, whatever is private cannot be inherited by a subclass because it's private. So a subclass inherits all entities for the superclass, which means methods and variables that are not private. But also they have their own instance variables and methods that are not in the superclass. So they have whatever is not private in the superclass plus whatever we declare in that subclass. And this is how we declare a subclass. So we say public class, say employee extends person. Extends is the Java keyword for inheritance. And we can word this in different equivalent way. So when we declare employee extends person, we are saying that employee is a subclass of person. We can say that person is the superclass of employee, or also that employee inherits from person. Now, notice one thing that I say, employee is a subclass of person. So there could be many subclasses of person. Yeah? But I say person is the superclass of employee. So given a class that can only have one directed subclass. Yeah? This is said because Java is called a single inheritance language. Other object-oriented languages may have differences. For example, C++ is a multiple inheritance language. But in Java, you can only have one direct superclass for a subclass. So, let's see a simple example. Let's suppose that we have this class called person, and as instance variables, we have name as a string, we have a date of birth, which is an integer, and we have, so these instance variables are private. Then we have a constructor person that initializes the name and date of birth. And then we have, well, you see we have getters and setters for the instance variables. So this is a standard class that we would write as we have learned in the previous lectures. Now, suppose now that we want to create a subclass of person called employee. So, you see, we start by having an additional instance variable called salary. Again, that's a private instance variable to this class employee. Then we have, well, you know what is there. What is there after? Is a constructor, right? So we have the same name of the class. We don't have a return type. That is a constructor. That I imagine should have an argument there, for example, to initialize the variable salary. And then we have setters and getters for this state. You see, so this would be all the code for the class employee. But we have declared this class employee as a subclass of person. So what we said before is that now employee, as is a subclass of person, is going to inherit all non-private entities from the class person. And if you remember, there we had, for example, get name, get date of birth, yeah? So, if we have an object of type employee, what method can we call? So, we can call set salary and get salary, of course, because we declared set salary and get salary inside the class employee, so that's fine. But also, we can call the methods in the superclass. For example, set name, get date of birth. So these methods, we didn't write this method in the class employee. But nevertheless, whenever we have an object of type employee, we can call these instance methods because they are in the superclass and they are not private. So, for example, this statement would be correct. So here we are saying string n equal emp.getName. So emp is an instance of employee. GetName is a method in person. Employee is a subclass of person, so we can call emp.getName. And that was a string. Similarly, emp.setName whatever string, that is fine. Again, emp as type employee is a subclass of person, a setName is a public method in person, so that is fine. It's inherited by employee. So all this will work fine in Java. So all methods that we can we have in the superclass, we can always call in the subclass. And again, the simple way to remember is that employees are persons, and so whatever holds for a person holds for an employee. So let's see. Now, it doesn't go both ways. Yeah. So if we have a person, so an instance of the class person, so we can have a string name n equal p get name. That is fine because p is an instance of person. Get name is an instance method in person, so that is a perfectly fine call to an instance method. Again, p set name, that again is fine because we have an instance method in the class person, fine. But suppose that we try to do p set salary and a number. Well, that will be a compile error. So what kind of compiler will you have there? So there, if you try to compile, you will see symbol not found. Okay? So symbol not found, it just means that the compiler looks for that method name in the class, and so as the set salary method, you look for the set salary method in the class person, but in the class person there is no set salary method, so that is not going to find that symbol set salary, and so you will have the compiler error symbol not found. And it makes sense because not all persons are employees, so they are persons that they don't work. So it wouldn't make sense, also logically, to have this as a legitimate operation, because set salary is only meaningful in the subclass of person where people have a salary, which are employees. Okay? So this is the basis. So this is the basis of inheritance. In this example, employees are also person, and so they inherit from the superclass persons the methods. So the way Java will work is that whenever there is a call to a method, it will look for a method first in the class which is the type of the object, and if it doesn't find that method there, it will look in the class superclass. And as we will see, it doesn't go forever. So in Java there is a superclass to all possible classes. So, and if it doesn't find that method name in any of the superclass of the type of the object, then it will say symbol not found. Okay, so this is the way it works with methods. What about variables? So in the employee object, we declared a salary instance variable, but in fact, they are going to be involved also other instance variables, the instance variables of the superclass, because employee are persons. So when you create a subclass of a class, of another class, when Java creates that object, it will create also space for the instance variables of the superclass. So when you create an instance of the employee class, then Java will create space also for the instance variables of the superclass, like name and the date of birth. However, if they are private, even if they are created, cannot be accessed. Okay? Again, this is a fundamental principle of access modifiers. Whatever is private cannot be accessed outside that class. So private instance variables of the superclass are not inherited, even if they are created when we create an instance of the subclass. So, well, here we're going to have a problem, because so when you want to create an employee with, you want to say the salary, but also you want to say the name and the date of birth. Well, you need to find a way in which you can initialize these variables of the superclass, even if they are private. Okay? You see, let's see what is the potential problem. So let's see how, well, we would want to proceed. So say we have a public class employee extends person, and then we have the constructor. So in the constructor, we want to give an initial value to the instance variables. So we have a public employee that takes 3 arguments. So the name of the employee, the date of birth of the employee, and the initial salary of the employee. And then initialize name, DOB, date of birth, and the salary. And so salary is, we declare the salary inside this class, but name and date of birth were declared in the superclass. So what would happen here if we write the constructor in this class this way, we try to compile, what would happen? What do you think? So this was person. So you see that name and date of birth are private in this class. And then we have employee. And in the constructor of employee, we try to initialize salary, which is defined in this class. But also we try to initialize name and date of birth that are private in this class. So this is what we are trying to do here. And this will not be allowed, so we will get a compile error. And so we are a bit, we got a problem there because, well, we need to give an initial value to these variables, to all of 3 of them, the name and the date of birth of the employee, apart from his salary, but we cannot do it with the constructions that we have seen so far. And so there is a way, and there is a way, so there is a new keyword that we should use for this situation. So last week in the labs, I heard some students that try to circumvent this by setting the superclass variables as public. No. So the state of the object stays private. So we shouldn't set instance variable as public. What we should do is to use the keyword super. So we have this keyword in Java, super, actually is a versatile keyword that is used for several things, but in the form that is used here is what it does, it calls the superclass constructor with the arguments there. So when Java, the compiler, see inside the employee constructor super and then a string and an integer, it goes in the superclass, so that will be the class person, and see if there is a constructor in the superclass person that takes as argument a string and an integer. And in that case, if that is the case, then it will call that constructor. Okay? So not difficult to remember, but it's important to remember because otherwise we cannot initialize the instance variables for this object. Okay? So, so the way we do it, hence, is we have the constructor, and then we call the constructor in the superclass with super, giving the appropriate arguments, so in the correct order and types. And after that, we will do the remaining things that we would do. For example, in this case, we are still left to initialize the salary, and so we do the assignment salary equal initial salary. So, for example, an application of this would be there if you have employee E equal new employee Michael Roberts 2311 63 28,000. So there, when we do that call with the new employee, so we are calling the constructor in the class employee, and the first two arguments, Michael Roberts and 2311 63, will then be fed as argument to super, and super will call the constructor in person. So then we will have a person of Michael Roberts 2311 63. Okay? Is that clear? Sorry? No. So a subclass can extend only one superclass. Right. So it will look for, remember, you may have more than one constructor in the superclass, but because of overloading, they must differ in the type or the type of the arguments. Yeah? So there can be only one constructor that will match the particular arguments and types that you put there. Okay? Because otherwise you would have two constructors that would take exactly the same type and number of arguments that wouldn't be allowed. Okay? So yeah, good point. So because of single inheritance and overloading, there is no ambiguity in the use of this term. Now, super, so this is one of the way in which super is used. There are other ways that we will see also later on to related. So it's a keyword that is used in several ways, but always refer to the superclass. Super. Also, there is another keyword in Java, this, that refer to the current class. So we have this and super. Few things. One important thing is that super, when it's used in this setting to call the constructor in the superclass, has to come first. So when you write the constructor in the subclass, you see super there is the first statement inside the constructor. And that is always should be that when you use a super to call the constructor a superclass, that super has to be the first statement in the constructor in the subclass. And also, as we just noticed, has to have the arguments of the constructor of the super have to match the arguments in the one of the constructors in the superclass. Okay, so now at least we have progressed to what? We know what inheritance is a relationship between classes. We know how to define it in Java by using the keyword extends, and a subclass inherits all non-private entities of the superclass. And now we know also how to deal with initializing private instance variables of the superclass by using this new keyword super. So at this stage, we have the starting kit for inheritance. So we know how to define subclasses, and we can then proceed further. So that was our starting kit. Usually, if you see in the literature, the graphical way in which inheritance is depicted is in this way, is a upside down tree. So on top, at the root, you have the superclass of all classes in that tree. And then as you go down, the children are immediate subclasses of the parents. So employee would be a subclass of person, student would be a subclass of person, so full-time student and the part-time student would be subclasses of a student. Okay? So say employee and student are subclasses of person, but they don't have any relationship between them two, apart having common superclass. Also, full-time students and employee are both subclasses of person, even if full-time student is not an immediate subclass of person, but is still a subclass of person because it's a subclass of student and student is a subclass of person. So being a subclass is a transitive property. If A is a subclass of B and B is a subclass of C, then A is a subclass of C. Okay, that makes sense. So when you are in doubt, just draw these trees and see if it makes sense from an easy point of view. For example, music bands has no relationship with person or with student. So we wouldn't have an easy relationship between those two classes. Yeah? So when there is no easy relationship, then they are separated and connected. In BlueJ, as you will see, when you create a subclass, you will see that the BlueJ automatically will create an arrow that goes from the rectangle in the interface showing that subclass, and the arrow will point to the superclass. So it's a very natural way of showing and graphical to show inheritance relationship. I insist, again, this is not a difficult thing, but I see over and over that there is confusion, is inheritance should be used for classes that are in is-a relationship. Often, so the most common mistake is to use inheritance for classes that have has a relationship. Yeah? So that is a very different kind of relationship. In BlueJ, has a some sort of has a relationship is showed in the interface with a dotted line between two classes. And also, as you will see later on, when you will study UML diagrams or object-oriented design, has a relationship, has a different name in object-oriented design, is called aggregation. Or also when the has a include all the parts, is also called composition. For example, if you have a car, so we say car is a vehicle. So there is an inheritance relationship. But wheels is not a vehicle. A car has wheels. A car has 4 wheels, but that is not an inheritance relation. So you wouldn't put an inheritance relationship between a car tire or a wheel and the car. Okay? So that would be an aggregation relationship. So, for example, if you have pen and paper, a simple example here. So, can you draw the inheritance relationship between the following classes? Car, windscreen, wheels, vehicle, car component, bicycle, road, motorway. So this could be names of classes. And how would you establish inheritance relation between these classes? This is one bit. So we have vehicle, and we already saw this before. Car is a vehicle, bicycle is a vehicle. So we would put an inheritance relation that way. So an upside down tree with the superclass at the root. But there no other class there would belong to this tree, because windscreen is not a vehicle, wheel is not a vehicle, and so on. So, but wheels and windscreen, those are car components. So a wheel is a car component, a windscreen is a car component. So we would have that inheritance relation between these three classes. We have still two left. And so motorway is a particular kind of road, so motorway is a road, and so we would have there. So we would have three trees of inheritance in this set of classes. With inheritance comes a new access modifier. So far we have seen public and private. We saw that in week 1. Private is that can be accessed and used only within the class. Public that is public, so everybody can access and use that. And now we have a protected. So protected is a keyword that restricts the access and use of that entity only to that class or its subclasses. Okay? So if you declare something that is protected, for example, a variable that is protected can be modified in that class, but could also be modified in a subclass of that class or in the subclass of a subclass of that. Yeah? So protected is not, I would say, a major keyword in Java, because still, again, you shouldn't use protected, for example, for instance variables. Instance variables have to be private. You may want to use for some methods so that its usage is restricted inside that class as subclasses, but it's not going to solve the problem that we just discussed, that we solved using super. Okay, so now there are a few additional concepts that are implied by inheritance. So we say that in the subclass inherits from the superclass whatever is non-private. And we say that, so the justification is that whatever is true of the superclass, it will be valid in the subclass, like all men are mortal, Socrates is a man, therefore Socrates is mortal. But sometimes the behavior in a subclass may have a slightly difference in the behavior of the superclass. So think, for example, well, this is a silly example, but suppose dog is an animal, cat is an animal, and assume that so the superclass animal has, as part of his behavior, to make a noise, yeah, an animal noise. Then you may think that subclasses of that class, for example, a cat or a dog, they have changes on that behavior that they inherit. Yeah? For example, a dog may bark, a cat may meow or purr. Okay? So, and that is something that we want to model in object-oriented programming. So we want to model that you inherit the behavior of the superclass, but sometimes you may modify the behavior that you have inherited. And this is an important concept, and goes under the name of overriding. Yeah? So don't confuse overriding with overloading. They are completely orthogonal. So overloading we saw in week 1 is to use the same name for a method, as long as you can make differences in the type or number of arguments. Overriding is a relation between methods in different classes, in the superclass and in the subclass. And is the fact that a method inherited by the subclass can be modified, even if it keeps the same name as in the superclass. So, for example, suppose that we have a bank account, our example that we have from week 1. So we have a balance, and then maybe we have a print statement method that prints the balance. Now, suppose that now we have a subclass of account, savings account, and in this subclass we want to have a method print statement. But this print statement for savings account, it does something a little bit different from the print statement of a normal account. For example, it prints the other details like interest rate and so on. Yeah? So in this case, while savings account inherits print statement from the superclass, we don't want to inherit print statement as it is. We want to have a different behavior for that method. And this is a case of overriding. Now, suppose in particular that what you want to do is that you want your method in the subclass to do whatever the method in the superclass does plus something else. Okay? So this is a particular case of modifying the behavior. So for example, for a savings account, you may want to print the statement as a statement of a normal account, plus you may want to print other informations. How can we do this? Again, we go back to what we were saying 20 minutes ago. We can use the keyword super. Yeah? So we are using the same method name, print statement, and then if we want inside the print statement use the print statement of the superclass, we just write super.print statement. And that super used in that way as a super dot something is going to look in the superclass for the method that is after the dot. Okay? So what we could do, it would be something like this: public void print statement, super.print statement. So what happened there is that when Java will find this statement, it's going to look in the super class for a method called print statement, and will execute that method. So that will be done, and after super.print statement, whatever additional behavior we want to this method to do, we just write the code. Okay, let's have a 4 minutes break, and then we will continue.
Question from the last platform. So we said we use super, so we refer print statement from the super class.
Yeah.
But here we use this somewhere compared in the super class, or that's what I
We are, so here we say we have account, and account has this print statement method. Now we have a subclass of account, account, and now we use the same name as in the superclass, but now we want in this method to do whatever print statement was doing in the superclass plus something else. So how do we do that? We do super.print statement. This statement here is going to call this. And then we do whatever we want. Yeah?
Thank you.
Okay. So let's see. So let's see a little example of inheritance and the concept that we've seen. So this is, we have our account class. Account class is pretty much the one that we've been using so far. And now here I'm just declaring a subclass of account. So say savers account, extends account. So I'm using the keyword extends, so I'm creating a subclass. And I'm declaring in this subclass a new instance variable interest of type double. This is private. And also in the superclass, I have still the balance, which is private. So this is now an appropriate constructor for this subclass. So it's a savers account and has as argument we want to initialize so the interest of this class, but also the balance of instance variable of the superclass. And so this is what we were talking about before. I'm going to call the constructor of the superclass with super, and I'm going to give as argument balance. So what happened now is that Java will look into account if there is a constructor that has a type double. So here is account, and yes, here it is. So it find a constructor with a double argument, and so this will be the one that is going to be called at this point. And I'm still having to initialize this variable, and this is what I'm doing here. So you see, I'm using the keyword this, and as I said before, this refers to the current object. So this interest is going to refer to the instance variable interest in this class. So is this. So this dot interest is going to refer to this, not to be confused with interest, which is just this name. Okay? So interest as this is a parameter. It doesn't matter what this is. So if here I put x, that's fine. It's no problem. Okay? But interest here as is not just any name, is the name of these instance variables. Yeah. So if you want to without ambiguity to refer to an instance variable, you can always use the keyword this. This is the keyword in Java that refers to the current object. Okay, so this is about the constructor. And now I'm having, so I'm adding two methods here. So what I'm doing here is basically adding interest to the account. And so here, what is this? This is an example of what? Well, so I have a method. This is a method name because there are parentheses after. This method is not inside this class. I didn't write the code. So well, should be a method in the superclass, is this. So it's an example of inheritance. I'm just calling a method in the superclass, and here I'm just so adding to the balance. Deposit is adding to the balance the interest for those months according to the formula. This is the formula you have also in the booklet. And that is then I added a main method here to run this. So this is a simple example. You see, so I'm basically in this savers account, I have all the functionality of the account class as demonstrated by using this deposit. So I got everything that I have here without having to rewrite any of this code. I'm just using, and then I'm adding some functionality, the functionality of handling interests. That's it. So this is the power of inheritance, is that now if you extend a class, you don't need to rewrite any of the code in that class. You can just use it through inheritance. And as we will see, I mean, for example, inheritance is in Java is used greatly, for example, for graphical user interfaces, for graphics, animation. You wouldn't have any of this in Java without inheritance. So typically, as we will see in a GUI, when you create a graphical user interface, you are extending a class in a graphical class in the Java library. So you don't need to write all the code for painting things on the screen, because you are just using that code through inheritance. Okay? You only extend the code, the graphic code that someone wrote for you. So this is a very important concept. Now, again, let's not, even if sometimes it may be confusing, let's not mix the class context with the instance context. Inheritance and overriding makes sense for objects. For overriding doesn't make sense for class method. So, but you can still, if you have a subclass of another class, you can still write a method in the subclass that has the same name and parameters as a method in the superclass. In that case, however, we are not talking about we're not talking of overriding. We are talking about hiding, and there is some subtle difference there, because class methods only refer to the type, whereas instance methods refer to the objects, and that makes some subtle difference. Here is an example. So suppose we have this class animal and has a class method hide. So that is not an instance method, say as a class method hide, that just prints something. And now consider a subclass of animal, say cat. And again, we have a method with exactly with the same signature, so it's the same declaration, public static void hide. And now this prints something else, so hide method in cat. Now suppose that we have a main where we declare, so cat, my cat equal new cat. So we create an object of type cat. Then we create an object of type animal, but the object itself is an instance of cat, but is an animal. Now, if we are going to call myAnimal.hide, what do you think that it will be printed on the screen? Hide method in animal or hide method in cat? So this is Java code, is correct, this code. So let's see again. What happened here is that we have a subclass and a superclass, and we have in both classes a method with the same signature. Now we create an object calling the constructor of cat, but the type of the object is animal. And then we call on this object, myAnimal, the method hide. Now, well, there are only two options. Either we see hide method in cat, or we see hide method in animal. What do you think? Have a guess. Cat? Well, what we will see on the screen is hide method in animal, because these are class methods. These are class methods, hence they are not concerned what the object is really, if is a cat or if it's an animal. They are only concerned with the type of the object. And the type of myAnimal, remember the type is in the leftmost side of when we declare that object. So myAnimal is declared as an object of type animal. Hence, myAnimal.hide will call the static method, the class method, in the class which is the type of myAnimal, which is animal. Okay? So that is an example of hiding, type hiding for class methods. So, so we have this similar phenomenon. When we have a subclass and a superclass, we can use the same method, the same signature of a method in subclass and superclass. If we are talking about instance methods, then this phenomenon is called overriding. If the methods are class methods, the phenomenon is called hiding. And there are some subtle differences, because hiding is going to call the method, the class method, in the class of that object, whereas in the instance method is going to call the instance method in the object constructor, in the class where the constructor where we initialize the object was. Okay, so if we have in the example that we saw here, so if I do something like this, let's say, Okay, so here I have get balance in the superclass. Now I'm rewriting in the subclass. So this is an example of overriding. So now if I'm going to have an object of type savers, an object created as an instance of savers account, and then I'm going to call get balance, it will always call this get balance because it's the get balance for that object. Whereas, so it's the other way around. For the hiding, for class methods, it would call the type. So if the type of the object was account, it would call this get balance, otherwise this. Now, there is something that, so here, this important thing here is animal by animal equal new cat. So we're going to explain what this is. This is very important in Java. It's an example of the substitution principle. We haven't seen that yet. But we'll get there with this concept of polymorphism. So now things start, I need a bit of attention because things may start to be complicated unless you pay attention to this. So we have seen examples of, say, car is a vehicle, bicycle is a vehicle, so car is a subclass of vehicle, bicycle is a subclass of vehicle. Now, consider some statement that we describe at the level of a vehicle, yeah? So, vehicle are things that move, so we can think of start vehicle, release brake, accelerate, apply brake, stop vehicle, yeah? Now, these statements, we are not talking about, say, a particular vehicle like a car or a bicycle. We are just saying about a generic vehicle. And this statement makes sense for generic vehicle, yeah? It makes sense for a car, it makes sense for a bicycle, it makes sense for a truck, yeah? But we can state them at this abstract level of vehicle without specifying if it is a car or a bicycle. Their meaning then may depend on the particular vehicle we have in mind. Yeah? So for a car, to accelerate means different thing than for a bicycle. For a bicycle, accelerate means pedal faster. For a car, to accelerate is to press the gas pedal. Yeah? Other vehicle may have a different meaning. Yeah? So the meaning is, may be different according to which type of vehicle we are thinking of, but the description can be done in very general term, at the vehicle term. These kind of statements, so that we can state at the level of a superclass, but that makes sense for all subclasses. So these statements are polymorphic. So polymorphic, etymology from Greek, poly, it means many, morph, shapes. So they have different shapes, they have a different meaning, these statements. But they can be stated in this abstract, more general way. So in Java, you can give this sort of statement. For example, if you had a vehicle class at the vehicle class level, and then these statements may have different behaviors according to which subclass of vehicle we are talking about. Okay? So this is what polymorphism is. It's a question will be in the tests, sometimes it will be in the exam when we assess on these things, so it's important that we understand. So, to make statements at the level of a superclass, and then these statements may have a different interpretation in the subclasses of this class. how this can happen, and here we go back to that line of code we were seeing before, is because there is something very important in Java that is called the substitution principle. Substitution principle says the following things, is that in Java, an instance of a subclass can take the place of an instance of any of its superclasses. So, if in your code an instance of a subclass, an instance of a class is expected, you can always replace that instance of a class with an instance of its subclasses. Okay? So this is a very general principle. You will never get a compile error. It actually is one of the important features of Java. So here are two examples. Vehicle V equal new car. Vehicle V equal new bicycle. So what we are doing there is that we should write vehicle V equal new vehicle. That's what we learn in lecture 1, right? So in lecture 1 we said type, then name of the object, and then on the other side new, the keyword new, and then the constructor. Yeah. So we would expect here vehicle V equal new car, equal new vehicle. Yeah. Now let's apply the substitution principle. Here the substitution principle says that an instance of a subclass can take the place of an instance of any of its superclasses. So here we should have a vehicle, but car is would be an instance of a subclass of vehicle. So we can replace this vehicle here with car, because car is a subclass of vehicle. Okay? Similarly, vehicle V equal new bicycle. Again, from lecture 1, here we should have vehicle V equal new vehicle, but substitution principle says that we can replace an instance of vehicle with an instance of its subclasses. Bicycle is a subclass of vehicle, so we can replace the vehicle here with a bicycle. Okay? So this is a very important. You see, what happened here is that we are making a distinction between the type of an object and what actually this object is. So the type V as a type vehicle, but actually V doesn't refer to a vehicle, it refers to a bicycle. So it's an instance of a bicycle, it's not an instance of vehicle, but has type vehicle. Okay? So these kind of variables are polymorphic variables. So this variable V is polymorphic because it can store instances of subclasses of a vehicle. Okay? Is that clear? This is very important. I know often students get confused. Well, usually are the students that don't attend the lecture, but so pay attention to this, yeah? So, now, car is a subclass of vehicle. If we see in terms of types, we can also say that car is the subtype of the type defined by vehicle. So vehicle is the supertype of car. So this is rephrased in types terms, the classes terminology. And so to rephrase the substitution principle is that subtype objects can be used where objects of a supertype are expected. Okay? So you can, wherever you have objects of some type, you can always replace that object with an object of a subtype. Okay? So here, what we saw there is at the level of a variable initialization, but the principle is general. For example, we can apply this principle to the arguments of a method. So if you have a method that has as argument something of type vehicle, you can pass to that method an instance of a car. Okay? It's just, again, a different application of the same principle. The principle is general. Yeah? So a method that has a type vehicle, you can pass to that method as argument an instance of car or an instance of a bicycle. That will be fine. You will not get a compile error. So let's see if we get this right. So here are some exercises. So animal, my bird. So here is the inheritance structure we are going to consider. And now let's say I do animal, my bird equal new bird. Would I get a compile error? Yes or no? So raise your hands. Is this okay? Okay. Does someone think it's wrong? Okay, so it's an application of the substitution principle because here I should write animal, my bird equal new animal, but bird is a subclass of animal, so substitution principle, this is fine. It's good. Mammal, Felix the cat equal new cat. Raise your hands, you think is this correct? It's more indecision than before. It's the same principle as before, so mammal is a superclass of cat. So here I should have a mammal, Felix the cat equal new mammal, but cat is a subclass of mammal, so substitution principle, that's fine. I can replace this instance of mammal with an instance of cat. My bird, Tweety, equal new bird. Is that fine? Raise your hands. Good. That's my bird is not a type there, so this is a compile error because that type doesn't exist. Dog Snoopy equal new mammal. Is that correct? Raise your hands. Okay, so that was a trick question. This is not correct. This goes in the other direction because we have dog is a subclass of mammal. So here we are trying to replace an instance of a class with an instance of a superclass of that class. That is not allowed. We can go in the opposite direction. We can replace an instance of a class with an instance of a subclass, not with an instance of a superclass. Here, so we are trying to replace an instance of a class with an instance of a superclass. No. Bird, sparrow equal new animal. No. Again, is in the opposite direction. We are trying to replace an instance of a subclass with an instance of a superclass. That's not allowed. Mammal, M equal new Felix the cat. What's the problem here? So the first problem is that there is no class Felix the cat. What is the second problem? Even if there was a class Felix the cat. No brackets, yeah. Constructors like method always have brackets at the end. So we know just by looking that this has to be wrong. Animal Billy equal new dog. Yeah. So it's again substitution principle. We are replacing an instance of animal with an instance of a subclass of animal. That's fine. So, so now let's see how can we do polymorphism in Java. So suppose that we have V that we declared before. So if you remember V, so it was something like this. V as type vehicle. So V in both cases here has type vehicle. So what we can do here, we can say V start. So suppose that we have a method starting vehicle, V release brake, V accelerate, V apply brake, V stop. It doesn't matter what V is, if V refers to an instance of car or bicycle. As long as the correct type vehicle, and as long as these methods are declared in vehicle, that is fine. Yeah? So this algorithm, so this sequence of steps is polymorphic. So if I ask you in the code for your mini project, can you show me some polymorphism, you should point to bits of your code where you have statements that are polymorphic. So statements that refer to a variable of a supertype, but then that may have different behaviors according to what instance that variable is. So let me show if I can. So let me show you a bit graphically what's happened. So in this animation, something that seems random is happening. So you may have different Snoopies going, but all the animation is just an application of polymorphism. So 5 Snoopies are created, and then the only statement that there are in these animations is to make a step. But there are 2 kinds of Snoopies. There are Snoopies that move left and Snoopies that move right. In the code, we just say move. So I'll show you. What you see moving there is what makes move there is this statement, is step. Now, S has type Snoopy. S has a type Snoopy. And then that array of Snoopies are created here. So basically, we create an array of Snoopies, and each one is, we toss a coin, and it may end up being a Snoopy right, a Snoopy left. And they just then, so the superclass is Snoopy, and then there are 2 subclasses, Snoopy move left and Snoopy move right. And we have this step statement in the superclass Snoopy that is overridden in the subclasses. So in the subclasses, Snoopy left is overridden to go leftwise in the pixels. In the right is overridden to go right, yeah? But the statement is a single one. So the difference in the behavior that we see is only due to the fact that this is a polymorphic statement, okay? So this is really the essence of polymorphism. You just describe one generic behavior, in this case step, so move, make a move, but then the meaning of this generic behavior depends on what particular instance S is. Yeah? So now you see that when we are talking about polymorphism, we are at this generic, we have something that has a supertype, like a vehicle, or is a generic Snoopy, the supertype. If at the compile time, the Java compiler, it may not be in general capable to know what particular method will be called at runtime. Yeah? So when we saw that step as Snoopy step, when we compile the code, the compiler, it doesn't know if step means that he has to call the step in the subclass Snoopy left or subclass Snoopy right. Yeah? So this is a decision what code is going to be called for that polymorphic statement is a decision that will be made at runtime. This is in Java is an important concept that goes under the name of dynamic binding. Dynamic binding, it means that the code that is associated to a method, it will not be decided before the runtime. It's not known at compile time. So static binding is that at compile time, the system knows how to resolve what code is going to be called for a method name, and the dynamic binding is when this decision will be resolved at runtime. So all this is a consequence of inheritance overriding. If there was no inheritance overriding, we wouldn't have this problem. So, for example, if we have v equal new car, v start, so there v has type vehicle, yeah? Then in that case, it will call with v start, for that v start, we'll call the method in the car class. But if v is an instance of bicycle, then at runtime it will call a method in the bicycle class. So v being type vehicle cannot tell the compiler what method to call because it depends on what instance that v will be instantiated to. As I said, so all this, there are so lots of concepts that are all around inheritance and overriding. And one of the most important, as we said, is the substitution principle. Please don't forget that. As I said, is not just when we declare initialize objects, like in vehicle v equal new car, is a general, so a method that takes as argument something of a type, will you can pass to that method an instance of a subtype of that type. So a method that takes a vehicle as argument, you can pass to that method an instance of a car or a bicycle that will work. But sometimes we may want to go the other way around. So sometimes we may have our code that is polymorphic, so it works according to the more general class, but we may want at some point in the code to know if an object is an instance of a particular subclass or not. And here there is another Java keyword, which is instance of. The idea is simple, is that instance of, so if you have an object and a class, and then you want to know if that object is an instance of that class or a subclass of that class. So object instance of a class, we return true if that object is an instance of a class, of class, or if object is an instance of any subclass of class. Okay? So for example, if I have Felix the cat instance of cat, would this be true? yeah, if Felix the cat was declared of type cat, would be true. Felix the cat instance of animal, true or false? Well, if Felix the cat is of type cat, then that would be false, because animal is a superclass of cat. Felix the cat instance of dog, again, so this would be false. If Felix the cat is an instance of cat, it would be false that is an instance of dog. My animal instance of dog, so say that my animal is as type animal, then yeah, is a subclass of dog is a subclass of animal, so my animal instance of dog is fine. Bird instance of animal, so bird is not an instance of an animal, is an instance of a subclass of animal. Felix the cat instance of mammal, Felix the cat is not is an instance of cat, which is a subclass of mammal. Tweety instance of mammal, so Tweety is an instance of bird, which is not an instance, is not a subclass of mammal. So let me show you a bit all this of work before we get too tired, because okay, so this is a little example to show all things that we saw today. We have a superclass. The superclass has a constructor, has an instance variable myState, has one instance method called myBehavior that print myState, so that myBehavior will print the state of the superclass, and then has a class method. So let's have, here we have three subclasses of this superclass. One is this subclass, so it's a subclass extends superclass, has a constructor, and that's it. So the only thing that my subclass 0 can do is really to use the inherited method from the superclass. My subclass 1, again, has a constructor, but has also something more, which is this method myBehavior. So this method myBehavior is a method, so remember myBehavior was in the superclass, so this myBehavior is just a method overriding a method in the superclass. And finally, we have a third subclass, so that has more things, so it's got a constructor, has so it's got this myBehavior method. Again, it overrides the behavior of myBehavior in the superclass, and in fact, so overrides in the way we were talking before the break. The first thing it does is call the myBehavior in the superclass. Here we are, and then it does something additional. My subclass 2 has also some additional behavior that is not inherited, and then has a method that hides, so this is a class method that hides a method of the same name in the superclass. Okay, so let's play a little bit with this. Let's see what happened there. We have this test class. So we start by creating an object S of type mySuperclass. But what is in this S? So what is S referring to? is not going to be an instance of my superclass. We are going to use, show you this last week, this conditional expression. So we are going to toss a coin, math random greater than 0.5. So this is like tossing a coin. If math random is greater than 0.5, then S is going to be initialized to be an instance of my subclass 1. If my math random is less than 0.5, it's going to be initialized to be an instance of my subclass 2. Okay? So you see here we are applying two things we saw today. The first is the substitution principle, because we should have my superclass S equal my superclass, a new superclass. So, but we are instead replacing my superclass with an instance of a subclass. In fact, we don't know which instance of which subclass we are choosing until runtime, because which subclass S is going to be instance of will depend from the value of math random that is only known at runtime. So here we have a substitution principle, but also a dynamic binding, because the constructor here is which one will be called is only known at runtime. Now here, so we have S as type my superclass, and here is a polymorphic statement. We are doing S.myBehavior. So my behavior is a method declared in my superclass, so that's fine. So there's no compile error. But it's polymorphic because what happened with this statement actually depends on what S will end up being an instance of. So if S is going to end up being an instance of my subclass 1, this will have a different behavior than if S is going to be an instance of my subclass 2. And this we will only see at runtime. But we can describe this behavior polymorphically by just saying S dot my behavior. This then we are going to call a class method. Again, this will only depend on the type. So remember, the class method, this is a case of hiding, but it only depends on S, the type, which will be my superclass. And here we're going to use instance of. So we want to check S could be an instance of my subclass 1 or could be an instance of my subclass 2. We don't know. But suppose that for some reason at this stage in our code, we want to know what S is actually an instance of. And here is what we do. So we check if S is an instance of my subclass 2. If that is the case, so if this condition is true, then we are going to redeclare S to have the type my subclass 2. This is what is done here. So this is called a casting object reference. So S, we are in this conditional, and so we pass this test. So we know that S is an instance of my subclass 2. So we are going to now change the type of S to the type my subclass 2. Why are we going to do that? Because we want to call a behavior of S which is not inherited. So if you remember, in my subclass 2 we had this method. This method, my behavior not inherited, is not in the superclass my superclass. Hence, if we were going to try to call my behavior not inherited in S, as long as S has type my superclass, we will get a compile error. So the only way we can call a behavior that is not inherited in a subclass is by having that instance to be casted in the appropriate subclass. Otherwise, we get a compile error. Let's see. So, well, let's run a bit and see. Let's try to make sense of what happened. Okay. Okay, so what was printed there? Okay, so the first line there, basically it tells us what happened at runtime. What happened at runtime is that S has been instantiated to be an instance of my subclass 1. Hence, when my behavior has been called, which is in this line, what happened is this my behavior has been called as the overridden my behavior method in subclass 1. This is why we found this printout there. However, the type of S is my superclass, hence the class method is the class method of the type of S, which is my superclass, and that's what happened there. Now, this conditional has not been executed because, so hence S instance of my subclass 2 was false. Well, we know that because we know that S was not an instance of my subclass 2, was an instance of my subclass 1. So that's my behavior. Then so this is, we found, we declare then a new variable car1 that has type my subclass. So, and this is an instance of my superclass. My subclass is a subclass of superclass. So this test is true, which means we're going to find this written there. So this is an example, other example of instance of. And then we have two, this is, so it's an anonymous instance that we create, it's anonymous of my subclass 2 with my behavior, and we should find what is there. So if we go my subclass 2, my behavior, so it's going to call the behavior of the superclass, and this is what we found there. First is going to call the behavior of the superclass, which is this. This is there, super my behavior, and then is going to extend the behavior there. And the last thing we found is so for a class method, we are creating an anonymous instance, again, of type my subclass 2, but we are calling a class method, but that is the subclass. So you see, this is now hiding the superclass method because my subclass 2 here, the type of my subclass 2 here is my subclass. Hence, the class method that is called here is the class method in the subclass, in my subclass 2. Okay, I think we are running out of time. So there is lots of things there, but are the most important concepts possibly we'll see in this module. So pay some attention, try to work out what's happened there. And we'll see you on the labs this week for the test. Thank you very much for your attention.
test? Is it going to be during the tutorial session? The lab
The labs, yes, yes,
Going to be a multiple.
yes, yes.
Please upload the code that you demonstrated or something.
Yes.
The animation bit.
The animation, no, is not good. All the other code is shown. Yeah, going to be posted. Yes.
Well, even if not that, as long as you have the most code that you can
Yes, yes, yes. All code is posted. Yeah.
that will
Yeah.
That's going to be focusing on free stuff.
Is it focus on week 1 and 2, but there may be some not in detail questions on week 2.
So it won't make the heavy on the food.
No, 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 no. It will focus on week 1 and week 2. It will make the things on week 2. It will focus on week 1 and week 2.
How's the form of the exams going to be like this?
Please, please, yes.
So, you know, it says free short. It asks us about to write code about one-line arguments.
Yeah.
So I don't understand what that is.
I did in the lectures last time. So those are, if you see towards the end of the week 2 lecture, but basically are the arguments that you get pass to the program. But if you go towards the end of the last week slide, also the recording is explained. Yes. Yeah. No, we focus on week 1 and 2. But we focus, there may be some questions on this, but the focus is on week 1 and 2.
This is ridiculous. Oh, is it much better today?
Which I didn't hear, well, I don't think I heard last week.
Okay.
Very faint, you could hear the muffle of the conversation there.
Okay, good, because people did complain, and then I think Allison or somebody called, and they said they came to fix it. I can hear myself now.
Yeah.
Perfect. Because last week was, oh yeah. That sounds good already.
See the comfy chair.
Oh yes, please. Take it. Should probably turn on more lights, shouldn't I?